Hello guys, my name is Lazaro and today we're going to be doing a LeetCode problem. This problem is called closest dessert cost. You would like to make dessert and are preparing to buy the ingredients. You have N ice cream base flavors and M types of toppings to choose from. You must follow these rules when making your dessert. There must be exactly one ice cream base. Okay, so out of our N ice cream bases, we can only choose one. You can add one or more types of toppings or have no toppings at all. Okay, out of our M toppings, we can choose a subset or all of them. There are at most two of each type of toppings. So this is very important for solving this problem. This tells us that for every single topping, we can either choose 0 for that topping, aka not choose that topping at all, choose to have that topping only once, or choose to have that topping twice. You are given three inputs: base costs, an integer array of length n, where each base cost of I represents the price of the ith base ice cream base flavor. So okay, now we're given prices for these base ice cream flavors, and as you will see, we'll also be given prices for the toppings. Because we're given a topping cost, which is an array integer of length m, where each topping cost of I is the price of one of the ith topping. The reason why the bold one is because, remember, we can have at most two. So if we choose two, it'll be 2 times the price of that topping. We're also given target, an integer representing your target price for the dessert. Now our goal here is to make a dessert with a total cost as close to target as possible. Now when they say this, make a dessert with a total cost as close to target as possible, this is extremely important because it tells us what type of operation we want or what type of minimization we're looking for. Since they're saying the total cost as close to target as possible, we want to look at the absolute difference between the price that we have currently built up and target. Then they're also saying return the closest possible cost to dessert to target. If there are multiple, return the lower one. So for example, let's say target is 17. Actually, let's say it's 18. We can make an ice cream flavor that costs 17, or we can make one that costs 19. Now their difference to target is both 1, is the difference of just $1 or one price value. But because of this last sentence, we will be returning 17 because 17 is the lower one. So let's look at the first example. We have a base costs array of 1 and 7, topping costs of 3 and 4, then target of 10. Now the closest dessert cost that will be as close as possible to 10 will be a combination of choosing base 1 for a cost of 7, and then taking only one topping, which has a cost of 3, and not taking 4. So our answer would be 7 and 3 together, and that will give us 10. In the second example, as you guys can see, we can choose to have base cost of 3, then choose to have one topping that costs 4, and two toppings that cost 5. And of course 0 that costs 100, and that will give us a grand total of 17. And that's the closest we can get to our target price. Now I usually draw it out, but I'm not going to do it for this case because I believe it's pretty straightforward from this description. And this shows just how important it is to read the description and fully understand what it is telling us. The main thing that we want to take away from here are really just 2 sentences. Oh, maybe 3 actually. Yeah, this could be 3. And that is that there's exactly one ice cream base. we can choose to have 0, 1, or 2, a quantity of 0, 1, or 2 for each topping. And we want a total cost as close to target as possible. Out of these three sentences, the most important one is this one. The reason why this is most important is because it basically tells us the answer. We want to consider every base ice cream flavor. And then for that base, let's iterate over the toppings. And let's ask ourselves, well, what would happen if we take 0 of this topping, so we don't take this topping at all. We take only 1 quantity of this topping, or we take 2. So this is enough information to already have an idea of how we want to build out our recursive function. So let's get right to the code. As we know, we want to be minimizing the difference between target and this price that we have collected up. So we want to have a difference variable initialized to infinity, and also an answer variable initialized to infinity as well. Next, we can get right into our recursive function. And in the beginning, we want to calculate the current difference between the price we have accumulated and the target. So that's just going to be the absolute value of target minus price. And if this difference is less than self.diff, then what we want to do is update the difference as well as set answer equal to price. Now, there's two scenarios where the difference is less than the total difference we've seen so far, or the difference is equal to the difference we have right now. When they're equal to each other, we want to make sure the self.answer is set to the lower price, the lowest price. So that's why we want to do self.ans is equal to minimum between self.ans and price. So after this, we want to do another check, checking if the position is larger than the topping costs array. If it is, we know we're out of bounds and we should just return. Now, if you guys are asking yourself, why do we have this if after checking for the differences instead of before? Well, the reason for that is because there's a delay in our price variable. And we can talk about that in just 2 more lines. For now, let's remember that we can choose at most 2. So for every quantity in the range of 3, so here this will start at 0, then go to 1, and then go to 2 and stop there. This is exactly what we want. We can either choose to have 0 of this topping, 1 of this topping, or 2 of this topping. So for every quantity, let's call this recursive function by incrementing the index and then setting the price equal to the current price plus the topping we were looking at times its quantity. And now you know why we have this if after calculating the difference. Because even if we're out of bounds, our price has still been updated, and we want to consider taking that. And the only way to consider it is if we first calculate the difference and see if it's less than self-diff. So this is what I mean by there's kind of a delay. Although we're out of bounds, our price variable is updated and there has been a difference, and we should take this into account. And this is really all we need for this recursive and backtracking problem. Keep in mind it's backtracking because if this current quantity didn't work, we will backtrack back to the function that called it and then increment it and go to the next quantity. But this is just for toppings. So now we want to consider starting off with every base. So for base in base costs, let's call this function starting off at index 0 and starting off with the price of the base cost. After this, we can just return the answer we have found to be the best or the closest to target. So let's run the code, make sure this works to see if I made any errors. Okay, and I didn't. So right before I submit, let's talk about this and see why I said that we only really care about 3 sentences. This first sentence right here, there must be exactly 1 ice cream base, tells us that we want to consider starting off with every base in base cost. This next sentence, where we want to find a total cost as close to target as possible, tells us that we're going to be calculating the difference, the absolute value difference between target and the current price we have accumulated. And that's the main variable that we care about, or the main number that we're trying to minimize. And then finally, there are at most 2 of each type of topping. That tells us that we want to consider only taking 0 of this topping, 1 of this topping, or 2 of this topping. Therefore, we know we only have to iterate over values 0, 1, and 2. And for every quantity, we want to multiply it, because we're basically saying that for a topping that costs this much, we want to buy this quantity amount of it. And as you can see from this, from just those 3 sentences, we have our whole code base already written out for us. And it told us exactly what we're supposed to do. So now let's go ahead and submit. And it gets accepted. Perfect. So hopefully you guys were able to understand how to solve this problem, and hopefully you guys really see why we only care about those 3 sentences. And just the importance of reading the problem description and fully understanding what it's asking from us. Other than that, I hope you guys enjoyed. If you did, please leave a like and consider subscribing. And thank you very much for watching.